So go ahead and try this warm-up problem. This is kind of just recapping yesterday. So I want you to write down the answers on your paper. So for number 1, you're going to underline the hypothesis, circle the conclusion. Then you're going to write the converse, inverse, and contrapositive. So take a minute to do that. And then you're also going to do number 2. So using the Venn diagram, you're going to write a conditional statement. So again, that's just a review from yesterday. Go ahead and do that. And then in class tomorrow, we will put some answers up on the board for that. Today, we're going to talk about biconditional statements. So those are an if and only if form. And so the definition of a biconditional is when the conditional and converse are true. A biconditional is basically a definition that is if the conditional and converse are true. So you can still have a biconditional, but it doesn't necessarily have to be true. The only way it is true is if the conditional and the converse are true. So we're going to take a look at a few examples. So our first example is our conditional is if a ray is an angle bisector, then it divides an angle into 2 congruent angles. So that is a true statement. So if we have an angle bisector, it's going to cut our angle into 2, and those 2 angles are going to be congruent. Now for the converse, we're going to flip that conditional. So if a ray is divided into 2 congruent angles, then it is an angle bisector. So again, that is a true statement. So what the biconditional is going to look like is we're getting rid of the if and the then, and we're putting an if and only if in the middle of it. So the example for the biconditional is a ray is an angle bisector if and only if it divides an angle into 2 congruent angles. So I have my first statement there, which is the ray is an angle bisector. And then I have my last statement, then it divides the angle into 2 congruent angles. Now, if you notice, there's no if in the beginning, there's no then in there. So we got rid of the if and the then, and then in between them, we put an if and only if. So now this would be a definition for an angle bisector because our converse and conditional are true. So our biconditional, the full thing is true, so that would make a good definition. So let's go ahead and look at another example. We have 2 segments that have the same length are congruent. So we're going to do the conditional and the converse and the biconditional, and then we're going to look at and see if that's a good definition. So the first thing is the conditional is if 2 segments have the same length, then the segments are congruent. So again, all I'm doing is taking those 2 statements there and I'm plugging in an if and I'm plugging in a then to make it an if-then statement. Then for my converse, I'm going to flip. I'm going to flip the hypothesis and the conclusion. So now I'm going to say if 2 segments are congruent, then they have the same length. So let's look at if those are true statements. So if 2 segments have the same length, then the segments are congruent. Is that a true statement? Yes. So if they have the same length, then they are congruent. And then if you look at the converse, if 2 segments are congruent, then they have the same length. That is also true. So our biconditional, remember, we're taking out the if, taking out the then, and we're putting in an if and only if. So I'm going to rewrite that as 2 segments have the same length if and only if they are congruent. And yes, that is a good definition because congruent means that they would have the same length. So now we're going to look at another example. I have an angle that measures 120 degrees is obtuse. So the conditional, again, I'm just adding an if and a then into that. So I'm going to say if an angle measures 120 degrees, then it is obtuse. So again, is that a true statement? Yes. If it has 120 degrees, then it is an obtuse angle because it's greater than 90. So let's look at the converse. The converse, we're going to flip the conclusion and the hypothesis. So if an angle is obtuse, then it measures 120 degrees. Now, it's kind of like the example we looked at yesterday. this is not necessarily true because just because it's obtuse does not make it 120 degrees. It could be any number greater than 90, less than 180. So that's not a true statement. So we're still going to write the biconditional. So the biconditional, again, I'm taking out the if, out the then, and I'm putting in if and only if. So an angle measures 120 degrees if and only if it is obtuse. And that is not a good definition because, again, we can have a counterexample. It doesn't necessarily have to be 120 degrees to be obtuse. All right, and then the last example, we're just going to write a biconditional off this. So we're going to look at the two statements that make up the biconditional. So the first statement is an animal is a bird, and my last statement is it has wings. So those are the two statements that make up the biconditional.